Hi everyone, my name is Lisa Yan, and I'm also under Nitin Chuan, and I am taking over for Giannis for NetSeminar. So you'll see a lot of me. Today we have Omar Baldonado from Facebook, and he leads the networking software team. Externally, Omar is on the board for ONF and co-lead of the Open Compute project. Before Facebook, he led product management at Big Switch Networks, where he drove the development and release of the initial OF-based application and controller. And today he's going to talk about how Facebook networking infrastructure has adopted SDN. So without further ado, here's Omar.
Thanks a lot, Lisa, and thank you all for having me. I know this is, well, when I was talking to Giannis and to Lisa kind of to kick off NetSeminar, oh, hey, I'd love to come and talk about it. From a networking perspective, I've been doing networking since the early 90s. Took David's class here way back when, and so you can blame him for whatever I know of networking. but really, it's been a great ride throughout. I was at startups in Cisco in the 90s, and then other startups, and like Lisa said, a Big Switch, and now this is actually my first time to be an operator of a network, and you kind of learn some things being an operator as opposed to being on the vendor side. So. I think just by schedule, I'll go for probably 35, 40 minutes, and then kind of open up for questions. Hopefully we can make it a little interactive, right? So overall, let me just start off with a couple of things about Facebook. I think overall this is like an exciting time in networking. I've been in it for a long time. It is an amazingly exciting time. Not just from my position on Facebook, but in the whole industry. Right? So, just to give you a sense of some of the infrastructure-related stuff that happens at Facebook, right? You may have seen that we've announced our own sort of how do we reach the next billion, 2 billion, 3 billion users, and we've got an initiative around drones, lasers, and satellites. Kind of our more practically, so that's kind of out there. Right. Literally. More practically, there's stuff like we're building our own switch. Right. We're building. We announced this back in June. We're building our own top-of-rack switch as well as the software that goes on top. We actually announced something. Trying to save power 10-15% in the data center. Amazingly, power in a data center is like the major driver of efficiency and all the designs of what we do. And so anything we can do to save power is big savings for Facebook. Finally, the last thing, if you saw this one, it was a couple of weeks ago. We just turned off one of our data centers, and this is just kind of fun. Like it's hard to imagine. Like, let's just take. We don't have that many data centers, right? We have half a dozen or so. And we just said, hey, let's take this disaster recovery seriously. Let's just try turning one of them off and see what happens. Right? Obviously interesting from a networking perspective, very interesting from an applications perspective. What do all the distributed systems do when all of a sudden masters and things get turned off in one of our data centers? And so that's the sort of stuff that's happening in infrastructure at Facebook. A lot of it has to do with networking. And let me delve in a little bit more into the sort of the research challenges that we face. I thought the best way to do that would actually be to start here. This is a picture of our Oregon data center, and overlay this. Right? You may recognize this person here, right? But you probably see some other folks from all around academia here, from Princeton, Georgia Tech. University of Washington, MIT. We pulled a bunch of top researchers in networking and said, why don't you come to our data center in Oregon, take a tour, post your pictures on Facebook if you do, take any pictures. But let's then also talk about different challenges in networking, right? And have a good open session around that. So I'll just go through a couple of topics that we wound up covering right there. So clearly data centers. Right. What does it mean to design data centers that hold, as a design point, say, hundreds of thousands of servers in a data center? How do you design that, right? And then you move on to things like, okay, that clearly involves fabrics. just as a point, like this actually came up. This comes up amazingly, like a lot. I was at SIGCOM last year, and I was bringing this up, and people were saying, "Oh, you use BGP in the data center?" It's a very common practice. For those of you who are in industry, you probably know this. For those of you who are in academia, it may be more of a surprise. We run BGP all the way to the top of rack switches. And that's a very common practice. It's actually like an RFC. It's actually a draft standard now, like running BGP to the top of rack. And so there are different, most of the major large hyperscale providers do this, different ASs, all different ways to do it. Do you private ASs, do you stub ASs, do you use confeds? What are the different ways to do it? But we talked about what are the challenges and what are the reasons to do that, what are the challenges with it. We covered programmable switches and the idea of, specifically we talked some about OpenFlow. More generally, we talked about what does it mean to have a really, really programmable layer. I'll go more into that a little bit. So outside the data center now, we talked about backbone, right? Facebook is building out its own backbone. What does that involve? It involves a lot of fiber, submarine cables, 100G optics and beyond. All this is what are the standards there? How do we even achieve that? What's going to be financially viable anytime soon? So that comes up. Protocols. Protocols are still in the network, right? There's no getting, as much as we may say, like, oh, wait a minute, protocols are sort of the way it's been done. It is the way it is being done. It's going to be done that way for a while. So we'll talk about that. So those are two portions of the network, data center and backbone. Then I was actually happy to see this. A lot of the professors were interested in operations. Right? How do we run the network? Right? And what is involved with that once you kind of got it all set up and running? How do you secure it? How do you automate it? How do you monitor it in real time? All of this comes up. I think also a lot of interesting research topics there too. Right? So operations may sound like just sort of the exercise left to the reader, but operations at scale and operations with a lot more efficiency and operations a lot more quickly, I think there are a lot of interesting research problems there. We covered a little bit about our edge of the network. Right? So there's the Facebook internal network. Facebook talks, it meets the rest of the network, and so what's involved in our edge? How do you get good traffic information from the edge? What's the packet size distribution that we're seeing at the edge versus within the data center, and versus the WAN? How does that affect the hardware we're buying and the design of the network overall? Talked a little bit about our CDN. So we're building out our own content distribution network. Finally, getting a little bit more to the higher layers, right? App integration. One of the advantages that we have, not everyone has this. Pretty much, we build the network, and then the people who use the network are like one floor down, or right across the hall, or in the next building. So we all kind of talk about. The big data team will come beat us up, like, hey, I'm trying to transfer 2 petabytes now. What's your network doing for me now? So it's good to be able to interact so closely with it. Controllers, I think probably a lot of folks in here talk about controllers. We've deployed some, we're continuing to build and deploy more. How do you do that? Assuming that you're not going to get to all of a sudden a global Uber controller that controls everything from host to mobile device. Right? How do you deploy controllers out incrementally? How do you have controllers coexist? Some of our challenges there. We get into the TCP part of the network, or the part of the network. Again, we can tune the stack, we can change the stack however we want. I'll just keep on going here, that's all right. There's a lot there, right? The point here is that networking, I think, is just incredibly exciting. There's a ton of stuff going on, right? And for those of you in research, there are lots of different areas. Hopefully this gives you a sense of, not just us, I know other companies are doing this, but it gives you a sense of the different types of challenges. Hopefully it inspires you to say, like, hey, this is, oh, that's a Facebook scale, web scale size problem. I want to spend more time on that. So the last thing is software. And I want to spend most of the time talking about software-defined networking and how we see that within Facebook, how that manifests, right? So like Lisa said, I used to be at Big Switch, software-defined networking, OpenFlow, work very closely with a number of folks here in this room on a number of OpenFlow-based initiatives, and SDN. And I just want to kind of explain how that maps into Facebook. Before I move on, any quick questions on this? There's a lot on this slide, but any overall questions about some of these things? I can take that. I'll just kind of distribute it out. Watching. Sure. Can we what we're seeing in the network? Then the rest of it is distributed systems, right? It's just, it looks like any other stack within, software stack within Facebook. We've got caches and APIs and interfaces. At least from an infrastructure perspective, every stack looks like this, where you're trying to monitor, you're trying to automate as much as you can, and you're trying to control. So from an SDN perspective, you could think of this as sort of like layers and applications built on top. It's not that clean, right? And I'll go into that a little bit why it's not, but it's the reality of how we run it. Actually, I also wanted to call out, there are a couple of folks from Facebook afterwards, if you wanted to talk. Nada and James, who are ex-Stanford folks, so from the last few years, and are part of the team. They actually work on some of the global monitoring and control systems. Just in case afterwards we run out of time, we can ask questions. So I get this question a lot, right? So given that software stack, right, do we do software-defined networking? Yes, but with some expansions. I would say, right? This is one thing I hear a lot of on the SDN side. If you've heard, who's heard that before? Okay, all right, we've all heard it. Okay, that's good. I think for a particular use case, it's interesting for like the network virtualization and how you deal with hypervisors. I think that makes a lot of sense, right? But this is the Facebook network, social network. This is not the Facebook. This is not fiber lines, right? This is that would be very expensive. This is the Facebook social network, and it actually draws the map of the world. Right? There's no map of the world behind here, right? This is just points of where everybody's located and their connections, and it winds up drawing most of the world. There's kind of a blank area up here where Facebook is not, but overall it draws most of the world, right? And the point of this, besides the scale, right, is there's a physical network here. There's a physical network, right? It's it has long-haul optical, metro optical, routers and switches, fabrics, This is by no means a simple underlay. Right? And there's no way we can make this scale by just plugging together things that we buy. There's a lot of software we have to write. Right? And so this is where I think software-defined networking, right? The underlay is a solved problem, is not. It is not. There's a lot of complexity we have there. Sure. Oh, sorry.
So, do we know about some feature of this network? Say, this ours, there are some.
About our physical network?
Or about this?
Oh, about the actual social graph? There's probably other folks that can answer that in terms of the actual graph characteristics of the social graph. There's actually a whole bunch of sort of parallel research around that in terms of large-scale graph analytics. How do you deal with 1 billion nodes and 200 billion connections, and how do you shard that out if you can? That sort of stuff. There's a whole branch of folks that deal with that. If you're interested, I could forward you to folks at Facebook that deal with that. Okay. Again, I was pointing out just from the physical network that underlies the social network here is not a simple underlay. So here's another thing we hear, and I am very much acknowledge that, hey, there is a very important part of separating the control plane from the data plane, right? The only thing I would ask folks to expand upon there is those are not the only two planes that need attention from a software perspective, right? So here's an example. This is a picture of one of our CLOS CLOS fabrics within our network, right? It's a multi-stage, however many, 3, 5, it's a multi-stage CLOS. From a control data plane perspective, we actually could have built this several years ago, like many years ago. We kind of knew how to build this. It's well known how to build that, right? The problem with it was, what if server 42 can't talk to server 42,000? Okay. And then some link in the middle of this is not working, right? It's a management problem, right? It's a troubleshooting, debugging problem, right? And what's the software that we have? We could have built this out, but we actually held off a bit and kind of built a bunch of the tooling that we needed to get this out, roll this out at scale, be able to debug and troubleshoot across it. Again, management problems, right? Where we needed to use a lot of software. Last thing about SDN, right? Oh, yeah, sure.
On the previous slides, are you showing networking switching nodes, or do you include compute or storage?
Hold on here. We are. I'm scooting myself. No, there are no servers. Oh, actually, I think the servers are down in here. These are racks, right? So there are no servers. These are all switching nodes.
Thank you.
Right. So my mistake when I say server 42,000 can't talk to server 42. It's like a node hanging off one of the top racks here. It's not. That's not server 42. Server 42 is kind of down, probably off of there. Thank you. So the last thing about that I would ask the SDN folks and folks here to think about, right, is this whole notion that transition and a hybrid network is sort of like this unfortunate, gosh, like it's better green field. It's better if you just kind of get over there to the other side where everything is SDN, right? And I would say that this is actually not, at least there are some folks that can run brand new networks, and their network is going to be completely SDN driven and OpenFlow based, and that's awesome, right? It's not where we are, right? And it's not where anybody who has an existing network finds difficulty in how can we get this new technology over into my existing network. Facebook, I think we're at the edge of pushing this, right? But I was actually just talking to a bunch of other network operators in telcos, right? The Verizon's actually more like the Orange and Deutsche Telekom, that sort of thing. Run major networks, and it's a cost challenge. How do you introduce this in, right? And it seems again like an exercise left to the reader, or gosh, wouldn't it be just better if you could start off fresh? But it's actually an important problem, right? So to emphasize that, this is a picture of our traffic. Oh, go ahead.
Do you think that if anybody gets to have greenfield in view to build a new data center every few quarters, are you going to tell us about why, even when you get to design it from things like?
Yeah. So here we go. Yeah. So this is I'll go into that, right? So here's the traffic of our network. Again, units taken out to protect the innocent, sort of. So this represents roughly kind of our traffic from 100 million to 1 billion users. So it's an order of magnitude increase in terms of traffic, in terms of number of users, right? The green is the machine-to-user traffic that's egressing our network. So you can't quite see, but it's actually going up, right? Because there's an order of magnitude increase in number of users. Although we've done a bunch because the users are always trying. It's a bandwidth-constrained environment. We're always trying to kind of save on the bandwidth of users. But inside the network, east-west, right? It's unbelievable, just the growth that we're seeing. And it kind of makes sense if you think about it, if you used Facebook when we had 100 million users versus when we used it with 1 billion users, you know that your Facebook page is doing a lot, right? Who's nearby? What ads can I serve for you from people who are nearby? What about all this? All the different services that are coming to play to pull together your Facebook experience is represented in the red. So nowhere in here, right, is there a place where I can say, you know what, I'm going to turn the switch and convert over to SDN, right? Even from a data center perspective, we are building new data centers, not quite at the rate of 1 a quarter, but we're building out new data centers. But even there, it's a big deal for us. I mentioned whatever, half a dozen. We're not going to say data center N+1 is entirely all green, right? It just we'll go incrementally. We'll say let's even take a rack, right? And I mentioned already earlier, it's layer 3 to the top of rack, right? So I'm peering BGP to a spine, the next level spine switch, right? So if I'm going to replace that rack with an SDN solution, it's got to speak BGP up to the top of rack, or to the next layer, right? Or let me even say the next layer. Let's take a whole cluster, however many dozens of switches, the next level of spine switches. Those things all then talk out other BGP and other protocols to their layer, right? So my point is, whatever unit we demarcate for, let me try this new piece, right? It's got to interoperate with other things that are there. Especially also then from an operational perspective, if you think about it this way, our data center in Prineville is just about 3 or 4 years old, right about now. And so when we buy equipment, things start decommissioning after about a 3 or 4 year cycle and start kind of rolling out. Right? So I'm going to decommission a set of racks or a cluster or a pod. What do I replace it with? Right? I can't just decommission the whole thing at once and then put in new. So I'm turning off things incrementally and turning on new things incrementally. So I'm constantly in this state of transition, of hybrid. I think even from an SDN perspective, like let's say I got all the way to OpenFlow 1.0 in one of my data centers, then how do I then incrementally deploy 1.3 or 1.6 or 2.0? Kind of, there's always this state of transition that's going to happen that I think we just have to approach.
One quick question on this slide, if I may.
Oh, sorry. Sorry, there are not many units on there, so I can
But
just...
yeah, and with every respect to your choice not to put units, you said from left to right it was 10x growth of your user base.
About.
Yes, about.
Yeah.
So would it be fair to assume that the green line is also about 5 to 10x, maybe the broadband connectivity of the users is less than...
In terms of our actual egress traffic?
Yeah.
To the...
So the green is about 5, 10x then as well?
It's not quite clear there because we do things like I said, we're trying to compress traffic. We work at the protocol layer. Do we use TCP? Do we use SPDY? Kind of what makes sense there. Also, I don't remember if these actually include our CDN traffic.
Okay, fair enough.
And CDN, as we build out our own CDN, that's definitely skews kind of egress traffic as well.
Do you use visualization?
Oh, meaning like, do we run like hypervisors with VMs on them? Yeah, we don't. Yeah, I mean, some parts of the network we do, but generally our production network is bare metal. Right? Again, we're not Azure or AWS. AWS obviously. We're not hosting people's VMs. Right? We host other developers. Right? We have people who connect in and use Facebook, but we're not hosting their VMs per se. We have our version of containers, Docker, job management, where you can say, oh, hey, things are failing over, and let's move them all over here, and my job needs this much resource right now, and please find the best place for that. We have all of that, definitely, but not necessarily the level of VMs.
Containers are virtual machines, and lightweight virtual machines. I had a question about your last.
Oh yeah.
I mean, they're just a better way to do virtual machines if you don't need to run multiple operating systems.
Yeah.
Obviously you can't run Windows and Linux. So the question about the last slide is it's just sort of a structural problem with Facebook, which is that the amount of computation that Facebook has to do for end users is actually not proportional to n, but proportional kind of to n squared.
So we've gotten this question before, right? So again, on that graph, like, wow, how can you sustain that?
That looks like what that's showing.
How's that going to go? Like you project out,
right?
Right. And so we actually have that problem on a lot of.
At least in the near future.
Yeah. And to a certain extent, we're not the only sort of infrastructure resource that has this problem, right? So that's the network diagram. If you draw our storage requirements, right, especially now that we're moving a lot more, we're doing a lot more with video. The storage requirements are doing that. Kind of the compute requirements are all doing that, and we're all. I think the structural problem, I would actually say it's like infrastructure. We're trying to keep up with the applications, the products. Right? So the product teams, and I'll come up to this a little bit later, are moving fast. They come up with. I remember here, Instagram video, right, came out last year, beginning of last summer, and the team that built Instagram video built it very, very quickly in a short amount of time. I can't really say it, but they built it very quickly. They said, let's try it. Bam! It went out to, at that time, their base 100, 200 million users, and it swamped us. Right? It's like from a video bandwidth perspective, like, holy cow, right? And but what are we going to do? We're not going to tell Instagram video only deploy it in South America, or they just go. They want to go as fast as they can. So same thing. That's kind of the we're trying to keep up as much as possible with the services, and as they think of more and more things that require bandwidth intensive, or that are bandwidth intensive, then we're trying to keep up with that.
So, you said you don't use virtual machines. You use a little bit of container.
Oh no, so we use a lot of the we use pervasively container-based technology, right? Just to use the common parlance for that. So job management, the whole C groups, and kind of the whole lightweight, that sort of thing, as opposed to running Windows inside of Linux.
So my question is actually, so do you have application-centric interface when you look at the SDN problem? Do you look at what's running inside the container? What is the networking infrastructure required by that application? Is there a resource constraint on that application that is running within a container? Are those problems also of interest?
Yeah, and I think that was going to David's earlier question of like, what is the interaction with the layers and other applications, higher layers, storage layers. We're definitely interested in that and building to that. I'll actually get to that a little bit more with the SDN. All right, so I've hopefully given you the sense that for us, SDN isn't a software-only thing. SDN has hardware involved in it, and I'll focus a little bit on this because it is enabling. The SDN hardware is an enabling substrate for us that we are looking to build out. Right? I would say we actually do a lot of the SDN concepts already at the controller layers, where we are centrally overriding what's happening in the network and controlling and steering what's happening in the network. So we have that. How we're doing that, we would love to do that against a more programmable substrate. So let's go into this stuff. I think I'll blast through this a little bit more because you've probably seen this stuff before, right? So most industry notion of what is programmability is this, right? Because let's automate what we are typing into the CLIs. So there you are. There it is. We actually have robots in our data centers, but not doing this. This is right, this is pretty obvious. One point to take away from this, right, is that probably some of you are involved in different standardization efforts like SNMP or NetConf or Yang or whatever else, right? In the end, a lot of the stuff, unfortunately, comes back to CLI, right? Because it's so patchy, right? I cannot I'm not saying multi-vendor. From one vendor, it's very hard to get consistent, like, do you support SNMP all the way through across all your devices, across every counter that I want? No, right? I have to go straight from the CLI. Do you support NetConf for every little knob I'm going to twiddle? No, there's a bug on it on this version of the so. All right.
Is that true of new vendors as well, from the last vintage of people who've come out in the last couple of years as well?
Obviously, they have less of a problem for that, but it's just not as big for newer vendors, clearly. From a programmability perspective, right, coming back to protocols, this is actually one of the reasons why we want to kind of do our own software implementations is to move faster with the protocols, right, that we want to do, right? We go to, mostly protocols are done this way. Again, this is probably well known to you. We ask for protocols to be standardized. We ask for them to be implemented. We wait. Right, and this is not what we want to do. It. So, and to say, like, I think we have a great relationship with our vendors, right? It's just that they're trying to serve a much larger customer base than us, right? They're trying to get things for Fortune 500 from all these people around the world. We're a very specialized use case, and so we just want to kind of move fast, right? This is, just for presentations, this is what the application teams are doing, right? They build an Instagram video in months, like, here, go, let's go. And they're asking us to keep up, right? So we have to, as the infrastructure folks, we have to kind of keep up with that. You may have heard actually move fast and break things. It's like a Facebook sort of mantra. Mark got up this year at our developer conference and changed that a bit. Move fast with stable infra. It's not as catchy, right? But we are the infra folks, and we have to kind of keep up with that, with the folks who are moving fast. All right. Programmability, I'll come back to that in a little bit. Openness, right? This is actually something that I think within academia and research, everyone counts on stuff being open, right? You look at protocol, you look at specifications, you look at things that are open, you're grabbing open source, right? Not, maybe Stanford does, but not everybody, not all the research institutions in the world have the ability to get into, NDA level kind of interactions with different companies to get access to doing things, right? So we like and advocate the concept of openness, right? Again, this is our data center.
So we conclude that with the vendors you have, the pain point is that one guy does it in Yang, the other guy does it in Portuguese, and the third guy does it in CLI, but the actual programmability in the hardware is there, meaning you can ask it to do what you want it to do. It's just that it's a pain in the ass to do it in a bunch of user UX manners, or the underlying hardware is still not programmable to your liking.
Well, the underlying hardware is programmable, right? So let's just take, again, I don't know who all, I recognize some of you from vendors, but let's just take well-known top of rack, right? A lot of folks use the same chip at the top of rack. If you look at that from everybody who sells a top of rack, they're all using the same underlying programmable hardware, programmable chip, right? We were actually going through swapping out potentially one vendor for the other. They have the exact same chip because the software layers exposed it differently and gave us more access, right? So it makes no sense, right? So wait a minute, why are we going to we're going to swap out hundreds of these boxes for these, and it's the same Triumph chip underneath. Right? So that was for us, one of the early proof points, we don't have the access that we want. Right? And again, most people don't want that access. I mean, most of the Fortune 500 enterprise aren't ready to start programming ASICs. That's okay. That's why I see there was a little bit of that case. Other companies I know are at that case who are trying to push other operators. There are a few, but I think we want to kind of move more toward that over time. It'll take some time.
I had a question.
Yeah. Oh, sorry.
I think this is a question probably you can answer the best because you were at Big Switch. Your involvement with OpenFlow and controllers which communicate via TCP/IP connections with the OpenFlow-enabled switches. Vis-a-vis the new model which Facebook is proposing, which is integration of servers and switches, and that sort of is an architectural modification to the pure OpenFlow idea, at least in my view. What is your thinking? Where do you think things are?
So it's a good question. I'll get to it. Actually, I think some of those concepts will come up, and then ask me again if it's not answered to what you're liking there.
Thank you.
All right, do you have one? Yeah, all right. Okay, no, it's all right. So openness. This is actually just, again, from an openness perspective, this is when we built our own data center 3 or 4 years ago. We published the designs for our servers. It got a lot of people in the industry thinking about oh, this is how they do it. Why don't I do it this way? Right? Just as a very simple example, I've talked about this before, but in case this has no case, right? Sort of vanity-free hardware, right? You've probably heard this before, but cases are fantastic at keeping things hot, right? They're great at putting a little, powered by whomever, right? But they keep it hot, right? So all of our servers have no cases, right? All of our servers have at least the critical components have no screws, right? So you want to swap out that power supply, that drive, and whatever, they're all snap-in, right? Because at the scale, you don't want people sitting there, again, going to this rack and kind of screwing stuff out, right? You got to be able to go quick, right? The ratio that we strive for, that I think we've published, is around 1 data center technician to 20,000 servers, right? In terms of and if you think about the failure rates of these things, they're going through there. We just swap out those things as quickly as possible, and to get that ratio, you need to design things thinking about how quickly can they replace things. These were some of the, even to the rack and the cooling and the power, there's a whole data center ecosystem now around the project that we started about 3 years ago called Open Compute. And the reason I'm bringing this up to you all is for those of you in the research community, I'm hoping that this is actually a place where you can play, right, and research, right, because it is the concept of open source software but applied to hardware. Right? So you can go and see how our designs, what are designs of top of racks, and how do they build that? Right? What are the materials? Previously, to do that, you would have to go intern at one of the companies, you know, or you work at one of the companies, right? But now more and more of these designs we're just going to publish and be open, and so that people can see this is how you design at first the top of rack, but also hopefully as we progress, like at the last OCP meeting, we talked about. Actually, when we move on to this, we talked about like a 32 by 40 spine switches, a little bit bigger, right? And then you can see those designs, right? I think a lot of this is probably, especially in this room at Stanford, a lot of you already are plugged into how the best things in the world are being built from this, in this perspective. But we think, hey, there are a lot of other places that could benefit. But also here, the more and more designs that are open for how you build switches and networking gear, the better. Right? We're even looking at some more standardization on the optics side, or more openness on the optics side for optical interfaces. And so that's an interesting place to operate. The other side is so that's the hardware, having open designs. Software is we're putting together building blocks. So this is the basic high-level diagram of a top-of-rack switch. You've got an ASIC that controls the fast ports. There's a CPU that runs all the control software. But then, what is that control software? Right? So you want to be able to program it. You need some sort of base operating system that you're going to work in, and you need to get that operating system on. Right? We're actually trying to keep this as open as possible. Right? So we're talking to folks within the community. They want that. That's not always Linux, right? They want that to be Windows or BSD or whatever. Fine, just load whatever operating system you want. Another open part here, a huge open part, is what forwarding software do we want to use, right? How does the actual switch do anything, right? There is, I think, a huge opportunity from a research perspective here to, once we have these open APIs and open toolkits for folks to start developing on top of a switch, I think there's a lot of room for innovation there too, right? I think there's been a whole bunch of innovation on the controller app side, right? We've defined within the research community OpenFlow and as an industry standard as well. And it's spurred a lot of innovation on the controller side. I can write all these applications that do this, match action, this, that, right? Innovation on the switch side is pretty much you're waiting for somebody to implement an OpenFlow agent for you, right? And you're just, hey, we've got the spec of 1.6. Who's got it implemented right now? And you're waiting again for the same folks who have access to be able to provide that. So we're hoping by opening this up, we get more innovation as well on the agent side.
Switchlight and Cumulus and NTS and all these existing, some occasionally free and open source switch operating systems that exist. Are you working with any of those or not?
So yeah, so within the there you go. So within the there are distributed protocol stacks, like I think we mentioned one, Cumulus, that implements traditional distributed protocols. Switchlight and from Big Switch implements more SDN OpenFlow. We're working with them and some other folks to say, bring your software so that other folks can build on it. The last point here before I move on, I think from a software perspective, you want to think about openness at all layers, right? This is a deliberately fuzzed out picture. You cannot tell what that is. But the whole point is you can tell that it's an architecture diagram, right? I mean, every architecture diagram that I've seen in networking software looks like this, right? It's got some agents here, some things talking to that. There's an abstraction layer here, and then they all look like this, right? And so, but they're all different standards, or they're all different. People want to implement their own way, right? So it's hard for me to say everyone agree on one standard here, and it could be closed, but then start to innovate elsewhere. I think we need openness and programmability at all the layers in a software stack. Okay, so last point, and this gets a little bit to your question about the kind of switches equal servers. So we announced a wedge, and let me just go into what it is. So it's a top of rack, 16 or 32 40 ports. We designed it ourselves. Our hardware team, the same team that designed our servers and our storage units. It's a building block for us from a networking perspective, and we're going to contribute this to the Open Compute project. In addition, we will also open source the software, so it will be a fully open hardware and software switch. Right? Two things to call out that I wanted to highlight. For switches equal servers, we actually embedded a whole microserver into the switch. Right? If you've done any switch development, most of your switches are somewhat underpowered CPUs, Power PC, Freescale, not a lot of oomph there. But they're cost optimized, right? But we kind of went the other way. Not a lot of RAM. Most of your phones in your pockets have more RAM than most top-of-rack switches. So, for us, the cost perspective, top-of-racks are already reasonably, there's a lot of competition already in that space, right? But so for us, we were looking at a lot of how can we make this easier to manage and run and operate and do our own software on it. So by putting a server on it, right, I can just download the Facebook image, the same Facebook image that runs across hundreds of thousands of servers already. I can just put it on my switch, right? And this is actually a huge win for us from a development perspective, and it costs put in that microserver. It's more powerful. It's got more RAM and everything, but the ease of treating it, the switches are not these exceptional. The hundreds of thousands of servers anyways. So, sorry, I went in there. So to follow into the FBOSS discussion, or into that server side, we built FBOSS pretty quickly. Again, we're not trying to be an operating system that you're going to sell that's going to support thousands of enterprise and mid-market and consumer customers, right? We needed to build a networking OS for Facebook. So all the stuff in the yellow, config management, environmental handling, even the stuff like Tupperware, sorry, that's our internal code there, containers and all, that is, that's all standard, right? This runs on every server in the fleet, right? So we just grabbed all of that and put it onto the Facebook switch, right? So as an example, we don't run SNMP, right? Why would we? So why don't we? Because all of our servers right now just push statistics up to our big data warehouse, right? And the same packages that are, how many clicks are happening to this ad campaign in the Philippines that somebody ran, that same statistics package that runs on all the servers, I can now push up what's the light levels on these interfaces and what's the bandwidth, egress bandwidth, and all that from the switch. I can leverage all of that. The way I configure it is the way I configure all of my other services. The stuff that is network specific is kind of over here, and we had to implement that. Right? To the point about kind of changing the control paradigm a little bit, all Facebook services implement as their method of IPC something called thrift. Right? It's like, to a certain extent, it's similar to Google's Protobuf, but Thrift is out in the community as an open source project. So every Facebook developer knows how to use Thrift, and so we put Thrift on top of our switch. Right? Underneath it, we could use whatever, right? We could actually wrap an OpenFlow agent. We could wrap an SDK directly. We can do whatever we want, but we put that's the layer that all of our software developers know how to use. All right, so then that's kind of the switches equal servers point, right? It's designed with the server side of it. We can run it, we can manage it like the rest of our server fleet, and we can also write code, just like anyone writes server code within Facebook.
Excuse my ignorance. So, first time I hear about Wedge, so it doesn't have a Trident or a similar switching?
Oh no, yeah, I mean, coming back to this.
It does, right? I don't need to.
Yeah. No, this is top of rack. It's Trident based. So coming back to this picture, right? Software. That's kind of our perspective on software. Let me go here. Whoops. Finding my build. This picture, right? I want to relate the whole discussion about SDN hardware. Right? That makes this part of the network more programmable, and it makes the job up here a lot easier. Right? Actually, it's the job right here a lot easier, because there's a layer here that collects data and changes stuff out of the network. Once that becomes more programmable, this job down here is a lot easier, and we can move faster there. We can actually expose more capabilities in the programmable hardware to give more ability to change, better statistics to collect, right? If we have that sort of programmable substrate. All of this, the distributed systems problem stays the same. Right? So from an SDN perspective, those SDN layers actually don't change that much. You might have more capabilities, but all the infrastructure has to stay. So that's pretty much it. Happy to take questions. Hopefully you got a sense of Facebook networking as a whole, but also kind of where we're pushing on the hardware side, where it's programmable, open, and a logic switch. So thanks. Questions?
I was going to ask, can you say a little bit more about the way, when you say BGP to the top of rack?
Yep.
It's presumably a lighter version than the normal full BGP bells and whistles with policy-based. All right. So what actually is that in practice?
So
how is it being used? What is it for?
Right. So currently BGP to the top of rack. So I don't remember the RFC. There is actually an RFC that specifies how you could build a layer 3 data center with BGP. The BGP implementation at a top of rack is actually much simpler, just from a pure protocol perspective, right? You're only talking a couple of ways up. You're talking to things down. You're not an aggregate transit switch in the middle of the network, right? So it's really just stuff up and down. The only caveat to that is sometimes we even run BGP actually on the servers themselves as a way to just advertise out, hey, what are the addresses that are down there, like from a VIP perspective, as you think about it from a load balancing and kind of the edge servers in our network. So that is one thing where it's talking BGP both up and down. Our use of BGP there in the data center has kind of evolved over time, and if you look at the RFC, they're probably different. We probably implemented different ways in that. Like for example, do you treat each rack as its own AS, and do you run eBGP from the top of rack up to the next layer? Right, that's one model. Or do you say a cluster is its own AS, and then you talk eBGP out of that? There are different trade-offs and just different parts of the protocol you wind up leveraging. From a policy perspective, I think most of especially the hyperscale, kind of the big service providers, like to do this. Just it's a extremely flexible protocol. You have all sorts of knobs to control it. You can override the routing decisions, and for us, actually, that is actually an interesting way for us to get programmability even at the existing onto the existing network, right? So I can have my software peer to a whole layer of switches, and then just override, listen to the routes from my peering as a way to override the distributed protocol, what BGP decided on its own. So I think there are a number of startups that have done it that way, and we do that as a way to kind of override with central control.
Second question?
Yeah.
You were first, maybe?
I was going to ask, you were talking about real-time monitoring. What frequency do you get updates from the infrastructure?
Yeah, so there are a lot of different pieces of the monitoring, right? So, and I would definitely encourage you to talk to James afterwards about some of this. So, monitoring involves, let's see, just I can break down into the planes, right? So there's like control plane monitoring, so the health of all the distributed agents, the BGP sessions, the tables, the amount of updates that we're getting, access to the fib. That there's a whole level of stuff that we can get there. There's the data plane, like how often do we just get raw statistics of errors, encounters, bytes, packets transited. There's management plane statistics. Like it's actually pretty interesting for us to know this router changed its distributed configuration. In a router in a distributed model, how many people are touching that every day? Right? That router, for some reason, at the edge, peering to these providers, changed 50 times last week. It's like, whoa. So that there's some statistics there. We do a combination of also, from a traffic perspective, active and passive sampling, or active probing and passive sampling. And so those all have basically different time scales that they deal with. Mostly from just how big are the data sources. Some stuff is we're monitoring. Some stuff is actually in the sub-second second range, and other things that we're collecting are in the minutes range.
Yes. So if I understood correctly in the beginning, in the introduction, you mentioned that one of the biggest, if not the biggest motivation for data centers especially, but in general, is power consumption management.
Yes.
And reduction.
Yeah.
So in the context of all this discussion here, what is the key optimization target for that?
Actually, so let me turn it on. I don't actually. So on the power side, yeah. I don't know if we have like a general target for, hey, what do we want our power usage to be? It's just we have to kind of examine all the different pieces. Let me give you an example, right? Like a load balancer, right? We've got 10,000 servers. It's going to spread out that load, right? So that everything gets served optimally, right? Great for performance, terrible from a power perspective, right? Because now I've just spun up 10,000 servers, and I've distributed a load across them. They're all 5% loaded, and it's terrible for power, right? So I've now got 5 different or n different rows to heat to cool. When if I could have influenced the load balancing to just optimize and run those servers to 85%, and I'm only using a couple hundred servers, and that's great, right? So that's an example of where your sort of traditional way of load balancing and doing forwarding might be influenced by power. Considering.
One more question.
Yeah.
What's your middle box strategy?
Right. Okay, that's interesting. So we have middle boxes, right? So we have things that are load balancers and different firewall layers and that sort of thing. It's actually simpler for us than I think a lot of companies, right? So we'll tackle the whole network virtualization thing of, hey, those few servers over there, those don't, and somebody clicked and they want a load balancer. We don't have that problem. So we're a little more fixed. We can just kind of design the middle boxes more statically.
They're under controllers' control.
Their control, yeah. I mean, they're from a provisioning monitoring perspective. That whole monitoring automation control layer talks to those.
Last question.
Oh, last question. Okay, sorry. I don't think you asked.
Can you talk a little bit more about disaggregation? Is it mainly a maintenance issue, or are you trying to better share resources and maybe quantify the gains that you're taking?
So there are two things to answer that. So disaggregation, if you ever have a question. Disaggregation from the network perspective, like within OCP, I think I talked about it briefly. It's a buyer's choice decision, right? So when I buy right now, I buy hardware, software from the same folks, right? We want to split that, right? I'm not going all the way to, we're not going all the way to sort of defining what controller and paradigm you're using, but at least you can buy software for people different from whom you buy hardware, right? Just like I do in other parts of the in other parts of the data center. When I buy from a data center networking provider, I would like to buy hardware and software separately. The other way disaggregation comes up is in the design of the overall racks, right? Which is probably just a. I think it's actually it's a really interesting problem for us, where we talk to the server folks and they're saying like, hey, how can we start putting a bunch of disks and storage over here and just have one CPU that's controlling the whole rack, and can we now put switching over here and I think we're just exploring it. That's all I can say. We're definitely looking at it. We have the flexibility because a lot of the hardware is our own, and so we can kind of Legoize it. If you say like, take out those blocks over here, take out the blocks over here, and make up what we want, which is one of the advantages of having built our own. I don't think I can say anything about where we're at on that. Thanks a bunch for everyone.